Okay, good to meet everybody. Again, my name is Steve Wallace, and I work for Internet 2 and Indiana University. I've got the Q&A window up, and I'll try to watch it and answer questions during the presentation. So hopefully that'll work. So again, welcome. Yes?
I was going to say, sorry, we'll also keep an eye on that for you, but go ahead.
Great. Welcome. So Frederick and I are going to talk a bit about MANRS. We'll start with, why does routing security matter? Why do we care about this? And we'll start with a little bit about how routing works. So there are roughly 70,000 networks across the internet that interconnect, and these 70,000 interconnect and sort of present to the user as one seamless network. But there are actually 70,000 networks run pretty much independently that interconnect in a particular way that presents sort of this uniform network where you can reach everything pretty much magically. They do this in part through a protocol where we exchange information. So these networks physically interconnect, but then they also have a protocol that exchanges reachability information among the networks. So network A might connect to network B, and network A will tell network B using BGP, here are the other networks that I can get to. And that's sort of in a basic sense how these networks interconnect and exchange information that results in the network knowing how to get everywhere. These routers build what are called routing tables from these announcements. So every network that I connect to, I'll receive via BGP notices from all those networks of things they can get to, and I will build a table where I note, okay, this network can get to this location, this network can get to another location, and that's how it all works. The interconnection of these networks and the sharing of information about what the networks can get to is based on the honor system. And it really is based on the honor system. In this slide, they depict that as a handshake. I'm going to talk a little bit more in detail about that handshake in a minute. The internet and the protocols that support the internet were designed and implemented before security was much of a concern. And back when the internet was much smaller and you could trust networks to communicate correctly. So in other words, if network A could get to a particular set of networks, you would trust that the BGP announcements from network A were correct, that those were actually the path, that was actually a valid path to get to those other networks. And there was no reliable way to check if the information coming from that network was correct. So that your only option was to connect to them and hope that it was correct. I want to talk a little bit more about the handshake. It's really not a handshake. It's not even a handshake when these networks interconnect. So I'll describe how a good deal of the internet interconnects. And I think it's surprising to most. So if I am a network, let's say I decide to build a network and maybe I'm going to serve residential broadband to a particular community. I could purchase internet connectivity from a provider, but one of the more cost-effective approaches would be for me to interconnect with a bunch of different parts of the internet directly. And the way I would do that is I would rent space in a co-location facility. Equinix is a company that manages these facilities, but they're not the only company. So essentially, I would rent some space and I would install some equipment. And the idea is it's a co-location facility, meaning that other networks are in the same space, in the same building or set of interconnected buildings. And once I had a point of my network in that space, I could use one of the online tools, one that's particularly popular is called PeeringDB, I could identify the other networks that were in the same building I was in. And I would send those networks a request. Can I interconnect with you? Can I physically connect with you? And can we set up a BGP session to exchange routes? And then I would complete paperwork about that, except there is no paperwork. There's no handshake. Much of the internet, much of those 70,000 individual networks are interconnected as the result of a handful of emails exchanged back and forth, and these networks sharing some common real estate. And there are no central records of these interconnections. So there's no complete authoritative map of what these interconnections look like. And they're very much ad hoc. And it's not quite as uncoordinated as it might sound. It is the set of people who actually establish these interconnections is relatively small. I would say probably a couple of hundred people are responsible for the majority of these interconnections. And so they're a community that gets to know each other. There's some meetings, annual meetings that they typically attend, and they get to know each other. But basically, it's pretty ad hoc. There are typically no agreements. These peering connections are set up, and very little thought was given to how we ensure that the information the networks are passing back and forth is actually correct. And so that's kind of the source of some of the challenges we have today. So given that backdrop, that a lot of these networks connect without formal agreements, and in the past, it's been difficult to ensure that they're exchanging good information, has resulted in a reality today where we have routing incidents. So we have cases where these networks are exchanging faulty information. It might be an accident, it might be on purpose, but the result is it can impact the performance and reliability of the internet as a whole. So in 2019, there were over 10,000 routing outages or attacks. So, you know, the network is big enough. There are enough of these interconnections that these interconnections are fairly disruptive, and they happen pretty frequently. About 40% of all network incidents are attacks. So that leaves 60% are sort of accidents. So accidents are still a big problem, and part of MANRS practices address both attacks and ensuring that your network will not be harmed as much in the case of an accident. And an incident that may happen in what you would think would be an isolated part of the internet can actually affect the internet globally. So a problem in one place can propagate and affect the internet in profound ways. Routing incidents happen everywhere. There's no part of the internet that's immune to this. As you can see by these graphs, that there are a lot of incidents in the US, but at the same time, if you normalize the incidents per AS, in other words, per network, the US becomes a little bit less dominant of a source of attacks or other incidents. But they happen everywhere. No one's immune. It's an ongoing problem. And as we rely on the internet more for more critical things, and the internet is growing in size, these are becoming a greater threat to the internet and what we're doing on the internet. They cause real world problems. And insecure routing is one of the most common paths for malicious threats. There are also insecure routing can be a reason why an accident was disruptive and able to propagate throughout the internet. Kind of read about these all the time now. So what are routing incidents? What are the kinds of things that can happen when you are just trusting each other to send you correct information? Some of the things that can happen are prefix or route hijacks. This can be intentional. A network can introduce a route. In other words, a network can say, well, I can get to this particular bank. And again, if these networks are not checking information they receive from other networks, the other networks might say, oh, okay, looks like a good path to a particular bank. And now I've hijacked that route for the bank, and I can essentially cause traffic to and from that bank to go to maybe a device that I've set up to be a man-in-the-middle attack and steal credentials, or perhaps I just make the bank unavailable. And if the networks have no way to determine that I'm sending false information, they can have a difficult time mitigating that. So this is an example where if you could build a filter that said, I know what networks you're allowed to send me, in other words, routing information to me from, I can filter and ensure that's all that I receive or all that I accept from you. Sometimes we have route leaks. Route leaks are typically an operator error, and an operator might be receiving routes from multiple networks, and they might inadvertently pass routes from one that receive from one network to another, and all of a sudden they're saying that they're a good way to get to another destination, sort of like a route hijack, but typically unintentional. And again, if the networks adopted the MANRS practices, including filtering based on knowing what are acceptable routes coming from different networks, you can mitigate this. Another attack is leveraging something called IP address spoofing. So if a network is not configured to prevent it from sending packets that indicate they've come from a different network, not the actual network addresses, but maybe a foreign network. Now, if a network will allow those packets to escape, then computers located within that network can use that feature to attack other parts of the internet. So if I have a computer sitting in a network that lets me make up my source IP address, in other words, I've been assigned an address, but if the network doesn't filter my traffic to ensure that I'm only sending traffic that uses that source address, I can then leverage that to attack other networks. And we'll talk about that a little more in detail. I know I talk fast, so I'm going to just pause here. I don't see any questions yet.
We do have a hand raised. So
Sorry. Yes.
that's all right. It's easy to miss. So Carlos, you have your hand raised. I'm going to allow you to talk. Feel free.
Well, I'm really sorry about that. It was not my intention. I'm sorry. I will lower it now.
That's okay. That's okay. Thank you.
And I've moved my window so I can see the next hand raised. So Carlos, thank you. Now I'll catch the next person. Prefix route hijacking. This is an example of when a network intentionally indicates that they're able to get to a particular location, and they might. Oh, okay. So, question: who manages peering DB? Peering DB has been a resource generally available to anyone. I'm not sure who actually manages it, but if you are responsible for an AS, you can request an account on PairingDB. For example, I have an account on PairingDB, and you can maintain information about your AS on PairingDB. And then the database is publicly searchable. So that's not a direct answer to your question. I can't remember the group of folks that actually manage PairingDB.
He's actually closer than you think because he sits here and it's me. So I'm in the board of PairingDB. So it's a nonprofit organization run by board members. So for example, me. But it is designed so that the community runs it, right? So the community owns all the information. The only thing that the nonprofit organization is responsible for is basically the infrastructure, making sure the website is up, making sure that accounts are being used properly, and that the right organizations uses the right accounts. So it's more of a what can you say, community driven or project. And there is a lot of administrators which work for PairingDB at a non-profit pro bono kind of way. So they kind of make sure to help everyone out with any type of inquiries. So, and it is really the only viable resource we have to establish peering in the world. So it is in everyone's best interest to make sure it's up to date and working properly.
And I also say that because there's a public view of PairingDB, to get a better sense of how it works, I would suggest you take a look at the public view. And for example, in the beginning, I talked about I would rent space in a co-location facility and check PairingDB. PairingDB lets you look for networks based on where they are physically, based on the kind of networks they're willing to connect to. They also provide a way for a network to publish the routing policy. And they provide contact information, which is very core. So there's a network I want to connect to, well, who do I talk to? And PairingDB provides that information. So it's a good thing to go look at. How do you keep the filters up to date? I'm going to get to that in 1 second. Let me go a couple more slides ahead. We actually have a slide with a couple of examples of some tools. So route hijacking, there are different reasons you might hijack a route. So you might hijack a route. Let's say you've decided that your particular community, maybe you're part of the world or somewhere else, you want to prevent them from getting to a site such as YouTube. So you might say, okay, I'm the way to YouTube. And maybe your intention is just to block YouTube within your domain. But if you leak that route, if you accidentally told the rest of the internet you're the way to YouTube, without the rest of the internet having filters in place to block that announcement, then they might decide you are the best path to YouTube, even though you're not going to deliver the packets to YouTube. And here's an example where sort of an isolated event resulted in a pretty widespread outage for YouTube. Route leaks are similar to route hijacks. It's more about intention. In other words, route hijacks are sort of done on, typically you think of them being done on purpose. Route leaks are a similar event where it's accidental. And the normal example of this is you have a network receiving routes from several other upstream networks, so several other internet providers, and they accidentally tell one provider about networks they're hearing from another provider. And so all of a sudden they become to that other network a valid path for destinations for which they're not a valid path. And again, if the network has, if the networks have filters in place to catch this, they can limit the effect it'll have. IP spoofing. The preventing of IP spoofing is these other the things you can do to prevent route hijacking and route leaks are actions you can take for a campus or an enterprise network, but there are also actions that are important to take if you're a regional network or a large national or international network. IP spoofing is usually best addressed at the campus or enterprise network. So at the very end network where the devices are, it's important to ensure that if a device is trying to send a network packet with a made-up source IP address, that you don't allow that. Because if you do allow that, that gives those devices a mechanism to attack another device in the internet. And the way that works is if an attacker can spoof their address, what they'll do is they'll change their source address to the address of the device they want to attack, the victim. And then they will send requests. They can be DNS requests or other service requests with that spoofed address. And so those requests actually get responded to the victim, because when the DNS resolver sees the return address where they're supposed to send the response, it's actually the victim they're trying to attack. And the way this works is there's certain requests that you can make where the response is much larger than the request. And so you can amplify the amount of traffic you could send to the victim. Why doesn't the attacker just send traffic to the victim? Well, two reasons. One is you'd be able to tell the attackers where the attacker is. And second, the attacker might have limited capacity to send traffic to the victim. They wouldn't be able to overwhelm the victim. When an attacker can spoof its address, it can send requests where it might send a small request to a DNS resolver, and the reply might be 10 times as large, but now that reply is heading to the victim, and the victim can't really tell who it's coming from. They're seeing it come from a DNS resolver, not the attacker. So that's an example where packet filtering. The other examples have been about filtering routes, filtering the routes that are exchanged via BGP. IP address spoofing is actually when you are you're checking each packet to ensure that its source address is a valid address within its originating network. So one of the questions was, well, how do you maintain the filters? That's a really good question. The filters are constructed from information that exists kind of in two different places. So where do you look? How, to build these filters, you need to look for information that are published in something called internet routing registries for most filters. And so there are tools and tool sets that are available that will that you can configure to automate the construction of those filters. So for example, you might have your network might peer with a particular other network, and you would look up in the internet routing registry what are the valid networks that network with which I'm peering can announce to me. What is reasonable for them to announce to me and for me to accept. And so I can use these tools to look that up in internet routing registries, and then to construct a filter to ensure that I'm only going to accept things that are reasonable to accept. But this only works if the information in the internet routing registries is maintained. So a huge part of MANRS is ensuring that networks maintain that information. Actually, this is probably one piece to really remember. You need to put things like filters in place, but those filters are constructed based on information that the networks have to maintain. And so for these to work, the community has to agree that there's no written agreement that govern how these interconnections take place, There are no federal regulations. There are no international regulations. So it's in our collective best interest to maintain the data in these essentially databases so that operators of the network can use that data to protect the network. So there are tools to do this. It can be a pretty significant part of the resources used to operate a big network to maintain these filters. The information in these databases changes, and so they're not static filters. To work well, they need to be updated on a regular basis. Okay, I set myself up for this slide. We're all in this together. For this to work well, we have to maintain the information in these records, and we have to make use of it. So when a routing incident happens, you want to make sure it doesn't propagate, that it is mitigated. In other words, it's constrained. It doesn't cause much of, or maybe any disruption. And the way you do that, in large part, is to ensure that there is data recorded by all of the networks that documents their routing policy completely and correctly, and that the networks use that information to harden their networks to be able to build these filters to ensure that incorrect information, whether it's done on purpose or accidentally, doesn't propagate and interfere with the correct operation of the network. So what's the solution? Mutually agreed upon norms for routing security. That is the brand for the initiative for network operators to do those things. MANRS improves the security and reliability of the global internet routing system based on collaboration among participants and shared responsibility for the internet infrastructure. Much of the collaboration is actually maintaining those records. So different stakeholders in the internet have slightly different views or different ways in which they can participate in MANRS. The practices are tuned. So if you're a network operator, it's a little bit different than an internet exchange point, and it's different than a content delivery network. So the MANRS Network Operators Program launched in 2014. A handful of network operators had the following goals: raise awareness of routing security, promote a culture of collective responsibility, help everyone understand this only works if we're all in this together, demonstrate the ability of the internet industry to address routing security problems. The internet has become such a crucial infrastructure for all of us that if the internet can't solve this working together, then it's likely that there will still have to be calls for regulations to require it, and those might not work as well as us figuring this out together. So MANRS it describes things people should do as actions, and the actions for network operator, filtering, big one. Filtering, again, this is filtering of incorrect routing information. So this is filtering what you send and what you are willing to receive on your BGP sessions. And again, the filtering requires you to look in some databases to know how to construct the filters. And so everyone has to maintain those databases. Anti-spoofing, I mentioned before, this is not related to BGP filtering. This is actually looking at the individual packets. And this happens mostly on what we call the edge. So the networks close to the user or the devices are the networks that need to provide a control to ensure that those devices are using addresses which are valid. They're not picking a device of another device out on the internet that they're trying to attack. Coordination among the networks. Again, this is sort of relates to maintaining the data. So part of maintaining the data is so I can construct the filters, but another part of maintaining the data is so that if there's a problem, it's easy to determine how to contact the network that may be having a problem. So how do I identify who the contacts are and what the mechanism is to get in touch with them? So if I'm operating part of the internet and you're operating another part, and I perceive there's an issue with your part of the internet, how do I get a hold of you? And part of that is ensuring that we have good records that say, here are the official contacts for folks that run this part of the internet. Global validation. So there's filtering generally based on information that is in the IRRs, Internet Routing Registries. And there's also sort of a general category called global validation. And what typically, in addition to using the Internet Routing Registries, there's something called RPKI. And RPKI is an emerging, it's been around for a while, but it's emerging, being adopted increasingly by the internet. And RPKI allows an owner of an IP network, so the resource owner, to cryptographically assert the valid origin ASs for a particular network. In other words, they can say this network should only come, or excuse me, this IP address should only be announced as originating from a specific network. And then the internet as a whole, when they see an announcement, they can determine if that network announcement matches that assertion. So how does this work? Well, it is a mechanism to prevent network hijacks and mostly network hijacks. So essentially, it's a mechanism to further assure that it's difficult or impossible to hijack a network. MANRS IXP program. So internet exchange points have special issues. When I spoke about the handshake and I talked about Equinix and how you might get real estate there, Equinix is also an internet exchange point, and they have infrastructure dedicated to that. And there are unique requirements of those sites. And so the MANRS IXP program is a set of actions that are tuned to the needs of internet exchange points. Some are overlaps with the MANRS for network operators. So they'll essentially ensure routing information is correct. Internet exchange points sometimes have infrastructure that sits in between these networks. And so many times the networks connect directly to each other. And so things like the filters would be applied by each network to cover this connection that they have in common. At internet exchange points, sometimes the internet exchange point itself operates infrastructure that provides routing updates. So the infrastructure itself needs to provide some of the same protections as the networks would provide. They need to protect their peering platform. Frequently, these can be large Ethernet switches. And so there are things that you would require of a community using a shared layer 2 Ethernet switch that doesn't really apply in a normal environment where networks are bilaterally interconnecting. And again, you need to know how to contact them if they think there's a problem. And they need to provide, because it's a shared, normally networks have sort of a point-to-point connection that they're not sharing it with others. but in the internet exchange points, there's this common fabric that is being shared. And so different tools may be required to ensure that participants in that fabric can understand what's going on and troubleshoot problems. So with that, if you have any questions about what I just presented, now's the time. And Frederick is going to take over the presentation.
Yeah, I'm going to open up the Q&A window as well so I can see it. Does not seem to be anything. So I'll take it from there. Thank you, Steve. That was a great introduction. Let's see. Oh, there's the chat. There we go. Now I have all the other windows open. Okay, cool. So I'm Frederick Korsbeck. I'm from Amazon Web Services, which is basically the ISP for all of Amazon and specifically the cloud kind of business we're running. So I'm starting off here with one of the things that I kind of started with when starting at Amazon. So I have a CDN and cloud program that was launched in 2020. I was actually joining the network operator program in 2014 when it was launched, when I worked for another place. So it was fun coming back again, representing another organization in a new type of format. So the CDN and cloud program is quite new. It does include typical CDN and cloud transit providers you would know, like Amazon, for example, but we also have members through Google, Microsoft, Facebook, and smaller players as well, such as Axiom and Cloudflare and Akamai. So one of the things we wanted to do there was to kind of leverage the CDN and cloud's big peering power and infrastructure, typically for the ones that are maybe not well versed in the peering ecosystem, is that these networks are typically the largest ones on the planet. They have extremely deep footprints in all parts of the world, and they are the source of a lot of the actual traffic on the internet today, given how internet looks like. So what we did in the CDN and cloud program was to kind of reuse a lot of the actions we had before from both the network operator program as well as the IXP one. And what we kind of started out with when we started this program was primarily working around RPKI. I would say that the year 2020 was kind of the year of RPKI globally. So that was kind of where we started off the discussion from, to how to deploy RPKI at scale, and if there was anything in particular we had to think about being extremely large networks. And from that discussion, this kind of program was formed. So just as with the other ones, we do prevent traffic with illegitimate source IP addresses, and this is especially interesting in the cloud sector, I would say, given that if there's a compromise of someone's machine in the cloud, right, like this could generate an extreme amount of traffic if used incorrectly. So this is actually something we had done for many years, but it is still very viable to talk about today to make sure that everyone else also gets this in line. We do encourage MANRS adoption. For example, one of the things, because what I do on my daily job when I'm not talking to you, right, is maintaining the peering relationships on behalf of Amazon Web Services. And one of the things that we talk with basically everyone on the planet right now is routing security. And just encouraging MANRS is a quite easy way for us to kind of make sure that all of the ones we peer with has what can I say, the bar is set already, right? So it's like, hey, if you want us to be happy and we have a good future relationship with each other, then maybe joining MANRS and making sure to fulfill these actions is a good way forward, because then we know what kind of the expectations are. So we've been using MANRS even before there was a program for CDN and cloud. We were kind of using MANRS as a way of encouraging others to reach a certain level. I also want to talk a little bit about business case. So if you need to sell this in the organization, for example, I had to sell it internally as well. That there is a business at the end of the tunnel as well. There's things other than just getting good security and being a good citizen of the internet that you can do. I'm going to take a second just to answer the two questions that I see here in chat. So from Mukhtar, so we have good practice for BGP. So that's kind of, that's a big question, right? So it depends. There is one book I could recommend actually that I've been reading myself. So Juniper has published a white paper on good practice BGP security. It is specific for Juniper equipment, but I do think that it is applicable to in general, right? So if you have Cisco routers or Huawei or Nokia or anything else, I still think that guide is a good one. I don't have the link handy right now, but I believe it's a white paper written by Melchior Alfmans, which is also a very active MANRS member, by the way, that's written that book. I think that is a very good start. There's also the NLog, which is a community project from the Netherlands that's been writing a lot of documentation around this as well. I think that is a very good start also to reading up on kind of good practice on BGP routing security. And I'm going to answer the third question there as well from Mukhtar. Let's see here. How to know the propagation, the information routing or the bad information routing take. I'm not sure about what the answer actually, or that question actually means, but there is multiple tools that can help you ensuring that you have routing consistency. And also if there's a hijack, or if you either was part of a hijack or the reason why the hijack existed, there is many tools on the internet can help you looking at that, like BGPmon, Curator Labs, Kentic, and some others that offer both free and paid services that can help you keep track of this. Yeah, we'll try to get all those links in the chat as well. Yeah, after the session is done, I can make sure that everyone gets it. And the second question there also from Mukhtar is, what's the difference between peering and transit used in BGP? So that is basically two different kind of commercial relationships between ISPs. So peering is typically when two ISPs decide to share traffic with each other on a settlement-free basis, which means that, for example, in Amazon's case, we decide with some ISPs that we want to share routes for free. So we give the ISP all of the routes to our resources for free, and they give us all of their routes back for free. This is kind of what happens over Internet Exchange Point chats and also in private peering. And I would say that maybe 90 to 95% of the traffic on the internet is done on one of these peering relationships. Transit is when you buy internet access from someone. There is a few networks in the world that does not buy any type of internet access. They're typically called tier 1 networks. A good example of that might be Telia Carrier, NTT, AT&T, GTT. Yeah, there's a couple of more as well. I believe the list is about 10 to 15, and there's always networks that tries to beat tier 1 networks, but it's a bit debatable exactly who they are. But they do not pay anyone else to reach anyone, so they make sure that all of the traffic they do is for free. So this is kind of the difference between those, and security does apply for all of that for anyone. So it doesn't really matter in terms of security and filtering if this is peering or transit. So I hope that answered the question. So a little bit about the business cases. So implementing these MANRS actions, right? So for example, it can signal that your organization has a security forward posture. I think that is extremely relevant today because I believe yesterday I was waking up in the middle of the night because I had on call because of a big routing incident out of India, for example. It was a big hijack that affected us and thousands of others. So not being that organization I think is a great way of signaling that we know what we're doing. It also, from a network liability point of view, right? If you make sure to sign your routes or at least document your routes so that others can help you filter, as well as filtering yourselves and propagating routing from or spoofing, so make sure you don't spoof. It does help for me as making sure your network runs well as well. and also, you know, for the rest of us, right? Like the rest of the citizens of the internet, because I mean, the internet is basically a community project, right? So if we can get these MANRS actions in place everywhere, like that will help the internet as a whole for everyone. We as users, whenever we need to, you know, get the recipes for the dinner and everything like that, you know, we want to make sure that that the internet actually works, right? And I think this is like the first line here, that the security is a process, not a state. I think everyone that is even slightly interested in cybersecurity knows that this is very much true. You can never be done, right? So it is always something that needs to be continuously improved at all times. MANRS in itself is not a one-stop solution, right? Like you need to apply the principles to your own business and to your own network. But it is general enough that it should fit basically every type of organization out there. And there is also new MANRS task force started. So for example, there is one for vendors that is kind of in the makings right now, which I think is great, where we see networking vendors joining as well and making sure that they get features and whatever they need to you know, so that their customers can take MANRS actions. So for example, why a service provider would join MANRS? So service provider, I guess, is the original group of kind of the MANRS members. So you will be part of a very important part to help solve global network problems. And you can lead by example to improve routing security. There's also a competitive value nowadays. And I've seen this, I would say, the last 9 months. There's been a lot of kind of debate on this, that, yeah, this is actually a very good feature to not necessarily sell, but it is a feature that sells, right? I've noticed just yesterday, for example, the big global carrier called Orange, which is based out of France, they were making massive marketing campaigns on their new RPKI efforts, which I think is great. I think they should make a big effort, because that kind of incents others to also do it. There's also the way, you know, you can be more than a connectivity provider and become a security partner instead. I think that's also important. And, you know, just looking from our own point of view, right? Like all the ISPs that we have contracts with and that we pay money for traffic, like we would certainly like to see MANRS principles applied for us to consider them a viable business partner. And I think that's something that more people should be thinking about. I mean, if you're an enterprise, like a smaller company, there are things here for you as well, right? So I would say that, you know, the smaller you are, the more important it becomes, the whole keeping track of your records, like making sure that you have signed your routes, if that's possible with RPKI ROAS, that's great. There's also maintaining IRR records is extremely important. So because we see a lot of that, right? Like old enterprises that hasn't really updated their data the last 20 years, and that data becomes very old very fast. So, and it doesn't take a lot of time to kind of fix it. So that I think is a very important step for a small enterprise to take. Then of course the whole source address validation is also extremely important, so that your resources is not part of like global DDoS and stuff like that. I think we have 9 minutes left. So I think I will skip kind of that. I will just quickly brief on something called a MANRS Observatory. So this is something that the MANRS community has been building. It is, you know, kind of like a lazy portal, right? Where you can keep track of a lot of various things. You can keep track of ISPs, how good they're doing. You can also keep track of countries and get statistics of kind of how these MANRS actions are upheld. And I've been finding a lot of interesting information in this portal, and I think this can also. I've also seen other companies use it kind of like a competitive edge when they try to sell services as well, which I think makes total sense. And that kind of also helps people do better, right? If this is actually used as a business driver as well. So I would definitely recommend everyone to check that out. I assume the link will be dropped somewhere in the chat to how to access this observatory. I believe it is open for everyone. I've been using this in my daily job, right? So I think it's a very important tool. I will quickly, as Manner mention about the ambassadors and fellows. So for example, me and Steve here, we are ambassadors of MANRS. We are going out and about to kind of help the community and inform. And I believe both of us are part of the kind of the training program where we will help people get better. So, you know, if you operate a community, for example, that would like to know more about writing security, how to implement it in certain features, or more RPKI, for example, which I guess is my specialty, then feel free to reach out. We're happy to talk with you in the context of MANRS or writing security. We also have fellows, which is up-and-coming leaders who believe that writing security is essential and ready to contribute. So we will help those as well to get the fellows off the ground and kind of get that deep into the communities. Because that's kind of, I think that's kind of where the work needs to happen going forward. Like we need to be able to reach deeper into organizations which may or may not have ever heard about MANRS, right? So given that we have 7 minutes left, I think I will kind of stop at this slide. So, you know, get involved, visit the website, make sure to attend these type of meetings, maybe even find a MANRS working group to join. I think that is kind of it. We need to leave a few minutes there for questions. And I believe Nick is going to help us finish this session, right?
That is correct. So gentlemen, are you done? Nothing more from you, Steve?
Yep.
Believe so, yeah.
All right. So the door is open. Anyone have any questions for Steve or for Frederick? Then I will move on to my wrap-up slides. I'm going to share my screen again. This is for our fundamentals participants. So this is, let me get this screen clear. I won't go through all these buttons. Basically what this is a reminder for all the fundamentals participants. What you want to do now that you've had the presentation is to think about an initiative that you want to perform relating to MANRS and contact your chapter coordinator, get a sign off on what the initiative might be. Then perform the initiative and have it posted to the chapter's media. And I think that is all. Yep. So I'm going to stop my screen share and let's just see. Yep. Right. And in chat, we also have a link to some of these suggested initiatives that you could do. If there's nothing else, then gentlemen, I thank you very much for your time today, and everyone who's participated today, thank you so much for your time. I hope this was insightful as it was for me. It always is, because MANRS isn't my forte, but I always get really into listening to this. And I want to thank also the support from my colleagues behind the scenes. So thank you, Kelly and Jolie. With that, thank you all for joining. Have a good day.
Thank you.
Have a good one.